Why am I such a meanie?
Yeah, man, mayhem everywhere. Welcome to the Hackaday podcast. My name's Mike Szczys. I'm editor-in-chief of Hackaday.
Hey, I'm Elliot Williams. I'm managing editor of Hackaday.
This is episode 137. Today we're talking about maximum PowerPoint, electric car hacking, Commodore Drive Confidential, and Tesla handles. Sad news Thursday of last week, Elliot. Clive Sinclair passed away. I should say Sir Clive Sinclair passed away. The creator of the ZX Spectrum, a personal computer from the 1980s that I think it's safe to say launched a generation of UK computer geeks and I guess, computer geeks around the world.
In the States, I think the ZX was the Timex Sinclair. They had some joint venture with Timex. I was a Radio Shack Tandy color computer kid.
Ooh, Tandy. There's a good line. Beige.
No, mine was pre-beige. That was the color computer 2.
Ooh.
Color computer 1 was silver and had these horrible little absolutely square keys on it.
I think the ZX Spectrums were black.
ZX Spectrums were black and had a chiclet keyboard.
And didn't they have like a rainbow design on the logo?
Yeah, that's the one.
They're iconic. I mean, really. And I think Bill Hurd in his book talks about using them as doorstops. I think it was at Commodore. So there was some healthy competition there. Now, Jenny List is one of those computer geeks whose love of all things 1 and 0 was launched by Clive Sinclair's product. And she wrote a nice in memoriam obituary post for him. So we'll put that in the show notes. Go check it out. But, someone who was foundational to history has passed, and it's nice to remember his life and his accomplishments.
This is a journey into sound. What's that sound?
What's that sound?
And now it's time for What's That Sound? This week I've got a kind of musical entry, but I don't want you to name the music. That would be too easy. Have a listen to this and see if you can figure out what kind of bizarre, non-traditional instrument is being played.
I know what this is.
Do you?
Yes.
It's the Overland theme from Mario Brothers, but that doesn't count.
It's a...
Ooh, good. Fantastic. First guess, Mike Stitch. You win the t-shirt. Oh, Hackaday.
It wasn't a guess. I know. That is a recognizable sound anywhere.
Yeah, super. Good.
Yeah. So everyone should be able to get this. And if you don't think you can get it, just sit and think a little bit longer because you know what this is.
I'm telling you, that's what the people who played Monkey Island were saying 2 weeks ago, Mike.
Yeah, I didn't get that.
It's also random. Like, some things, you don't know other things.
That is how it works, isn't it? That's
it is how it works.
But soon I'll know everything.
This is the nature of trivia.
If I keep listening to the Hackaday podcast, soon I will know everything. And I will have heard everything.
Every possible sound.
All right. If you, like me, know what this is, you need to head over to hackaday.com/podcast, where you'll find the show notes and a link to a form. You'll put your email address, the name you want us to use on the show, and what that instrument was in the wonderful Mario recording. And next week, we'll tell everyone what it actually was, even though you all already know, and draw for a t-shirt.
You're so gloating. Oh my God. Everybody, Mike got a What's That Sound? Everybody,
I got it like that.
Yeah,
it was like
did.
Dan
you
with
did.
the spherics.
Yeah, damn it. Yes, you did.
What do you want to do now, Elliot?
I don't know. Shall we talk about some hacks?
Let's talk about some hacks, yeah.
Did anything go on this week in Hackaday?
I couldn't resist looking at this one and bringing it to the podcast because it's bizarre and odd. It is like the animated GIF equivalent of playing a video game. It is a way of taking a snapshot of a video game that you played, sending it to someone else, and then allowing them to play that video game. The article that Christina Panos wrote on it is called Interactive Clips for Game Boy, Sit Back and Watch or Take Control. And Joel Frenzuk and Adam Smith collaborated on this using Game Boy emulators. And so you can play along with the Game Boy game. You get to a point where you want to send something that just happened in the game, and it takes a snapshot, like a save state. If you've done emulators before, that is like dumping the important registers and memory places from the game into a file so you can load them up again and start from right there. But then it also takes the ROM, the read-only memory that would be on a computer chip inside of the cartridge for the Game Boy, and it copies only the registers that were accessed during that little slice of the game that you're trying to share, and it packages them up and makes it so you can replay them online. And it's both interesting to me and kind of like, I don't know if that's a thing. So what's your take on this, Elliot?
I think it's fantastic. I think, if you were wanting to work on a speed run for a game or something, right? This would be the ideal tool for you. You could just go back to that part that's giving you trouble, start it up again, and then play that bit over and over till you get it right.
Yeah, I think for my interest in this, if they're talking about you can't just send the ROM to your friend because that's a copyright problem. But I don't think you can just send them these snippets either, because I believe you'd have to have most of the game engine code in there. Like, you get into this, like, is this fair use? And I suppose if you talk about memes or like animated GIFs, it's the same amount of fair use as animated GIFs are. Like, you can't play the whole game from this. You can just play like the little snippet.
Play this one little bit of the game.
Right, because like, for instance, if you go into the next room, let's say you're playing Mario and you're in the overworld, since we just heard that theme, and then you go down a pipe and you're in the underworld, there's a new tile for the world and the enemy, and there's new music and all that stuff, and none of that's going to be in the snapshot because it was taken in the overworld.
But that's not the point. The point is you want to show someone this bit of the game, or you want to practice on a bit for a speed run, or maybe you just only like the overworld.
Yeah, so I don't care so much about the end result here. It's done very well and it works. But the path that they used to get there is very cool. And I especially, Elliot, liked the visualizations where they take and they add like a pixel for each byte in the ROM. And then they put a color on what that pixel's all about. And then they show you just where the slices are from the recording. So you've got this like huge mosaic of kind of nonsense, or maybe it's actually the graphics. So some of the ROM is actually the graphic tiles and stuff, but some of it's code. And then side by side they show these are just the portions that were used. And in their analytics on this, they have decided it's between 3 and 13% of the ROM is being encoded into these slices. And it's kind of stays within that range. And I think that their opinion is that that's because you kind of get like 3% of game code all the time, and then another like 10% of graphics. But I mean, imagine applying this to some more modern games. I think it gets very difficult very quickly. But with this, it's nice to look at how can you actually monitor what is being accessed on the ROM through emulators. That's pretty cool. They pull a bunch of open source packages in and kind of stitch them all together. And then also the ability to play it back on a web page, I think, is very novel.
And if you haven't seen PieBoy, you should go check that out. It is a complete Game Boy emulator written in Python. I guess if you're the kind of person who understands Python better than you understand Game Boy machine language, which is basically anyone human, you should go check out PieBoy, because it'll give you a kind of readable insight into what's going on inside the Game Boy, which actually is the perfect segue almost into my next hack. Can I take it away?
Do it.
That brings me to the ultimate Commodore 1541 drive talk. A deep dive into disks, controllers, and much, much more. This is a talk given at the Vintage Computer Federation by Michael Stile, and he has given a number of talks on retro computing which have just blown me away. The other one that I'm thinking of right now is his Ultimate Game Boy talk. I'll throw the links in there. This is that talk except for floppy disks, and in particular the Commodore, like iconic Commodore 1541 floppy drive. I think whether you want to watch this talk or not, it's only a 45-minute talk. It's a beautifully presented talk. I think you have to ask yourself the question, how much do you want to know about floppy disks and their drives?
Yeah, it's disingenuous to say it's only a 45-minute talk because this is like a 5-day talk packaged incredibly well into 45 minutes. Like, it's insane how good he is at conveying a lot of information quickly in a way that's consumable.
And it's a really cool talk because the first 2/3 of it maybe is talking about floppy disks and this Commodore drive. And so you get into the hardcore details of like how the tracks are laid out, how the encoding works. You will understand things about floppy drives that you didn't know before, actually. But then in the last third, he actually kind of applies some of the stuff you just learned to show you different, clever, cool ways that people have hacked this floppy drive to make it run faster or to implement copy protection. And as much as copy protection used to anger me as a teenager trying to pirate video games, you have to say that the technical steps that they took to do all these different kinds of copy protection are really, really interesting. And I didn't appreciate that side of things as much until now.
I really got into the parts of this. Maybe I'm on a kick, or I just keep seeing these hacks that show the analog side of digital electronics. And this is so much part of that because I didn't know, how the tracks are laid out and how the sectors, how the sectors vary, like as you get closer to the center of the disk and that sort of thing. And that's really interesting. But when he gets into writing these gap regions in between the sectors, and he talks about how you have to have this gap region because if the motor that's spinning the floppy disk is running a little bit too fast, by the time you get to the end of that sector, you're going to be writing into the next sector. And so that gap is like the safety buffer in between sectors so you don't overwrite data.
Yeah, and there's all this trickery that I didn't realize was going on. I guess, I've heard the word interleaving before, but I didn't really understand why. And the idea is the motor wants to keep spinning, but after the read head has gone through a sector, it's got to have some time to process it. So it can't just read the next sector on the disk. It has to let the disk spin for a little bit while it's chunking on that data that it's just read in, and then read the next one. And so if you put data in kind of sequential sectors, it would have to wait until it spun all the way around to that same place again to start reading the next one. Instead, they're interleaved. So it'll go 1, and then it'll go 15, and then it'll go 32, and then it'll go 2. So that by the time it's ready to read sector 2, the disk has spun around to about that place. And this kind of low-level detail is really interesting in and of itself. This interleaving determines how quickly you can get the data into the computer. The coolest hack he shows off at the end involves this interleaving and a particular quirk of the Commodore 64. That is, its CPU was also doing graphics. When it's drawing one of the scan lines, and these are the so-called bad lines, where it has to do a lot of graphics processing. And because there was periodically this time when the CPU was caught up, this meant that the interleaving of sectors on the disk had to be spread way out because it couldn't tell how quickly it was going to get to the next one. And Michael shows through a combination of a bunch of really clever hacks. If you're willing to turn the screen off while you're loading from the disk, you can increase your disk read by something like factor of 20. Because all of this cascades, so you can read faster from the drive, so you can pack the sectors closer together. As really, really, really clever hack. And apparently these and other were figured out shortly after the floppy drive was released, and people made aftermarket ROMs that you could put in your Commodore 64 drive to make it read faster. But then the ultimate hack, which was this 5-byte in, 4-byte out encoding that the CPU had to do, wasn't actually figured out until 2013 when Linus Akeson figured out how to do basically a lookup table to make it so that the computer could actually read the data in as fast as the disk drive could spit it out. If you think this stuff is old and buried, you're wrong, because it'll give you a lot of insight into kind of modern processes, but also like there's still open hacks to be had on this now, whatever it is, 40-year-old floppy drive. Really super talk. Absolutely check it out.
Well, just think of the millions of people that sat there listening to these drives belch and sputter and had no idea the amazing universe that was going on inside. I'm on to a 3D printing hack for the next one, electric radial RC aircraft motor. This is a faux radial motor, I guess, or faux radial engine. So if you would have a radial engine on an aircraft, think of a prop plane that has like the pistons all pointed towards the central shaft of the prop. And when they would push, there'd be like an offset crank arm on the propeller. And when they push that, they'd push that crank arm away. So if you synchronize each of those pistons around the axis of that propeller, you would get each of them firing, in sequence in order to keep pushing in the same direction. This looks like that from the outside, and it's not that at all. So you have 3 motors whose shafts are pointed towards the axis in the center of the propeller. And then they have gears on them that then turn one master gear that's on the propeller. And it's interesting to me for a few reasons. One, it just looks cool, and that never hurts. But 2, I look at this and I'm like, I wonder if those motors would actually be interfering with each other. Because unlike a piston where it's like an internal combustion, so there's an explosion, it pushes the piston, and then that piston is kind of freewheeling after that point, so it doesn't interfere with the others. The electric motor is always turning, and if you have one that's turning at just a little bit different speed than the others, don't they kind of interfere with each other, Elliot?
The kind of naturally faster motor is going to be driving the other ones a little bit.
Well, and that's what I was wondering, is if you can build some monitoring on the current draw for the motors to find the sweet spot on each motor. If you have one motor that's turning a little bit faster, then it should make a motor that's turning slower less efficient.
Or it'll help it along. I mean, I think they obviously all end up at the same speed because there's only one propeller turning in the end. Whether one motor gets hotter than the other, though, I guess you could find out by just feeling them, right?
Right. Well, Kendon Yap does a great job of showing the different experiments that are going on with this, including switching out propellers and then also, mounting it on a digital scale and seeing how much force it can generate while the propeller is spinning. And so just a single motor with a propeller attached to the shaft is going to give you 170 grams of force. Triple motor is 490 grams of force and is going to have just a mathematical loss of 20 grams. So if you took 170 times 3, you get 510, and this is 490. But I would take those with a grain of salt. I mean, it's really difficult to empirically claim anything based on those numbers, and they're kind of all over the place based on the geometry of the propeller and the RPMs and a whole bunch of other stuff. But the fun is not over with this one yet, Elliot. In the comments, you'll find that LeClairon says, you could actually turn those motors so that they were like the Duke engine. And I had to look this up. Have you ever seen the Duke engine?
What's
Elliot?
a Duke engine?
Oh my gosh. Did you click on this link that's in the show notes here?
Okay.
It is crazy balls. So if you think about the pistons on a radial engine pointed towards the shaft of the propeller, if you turn them 90 degrees so that they're parallel to the shaft of the propeller, what you then need is this kind of like spinning dinner plate, like oscillating dinner plate. If you spin it and it starts going like wow, 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 like that, except for that dinner plate is what's getting pushed at by the piston, and that's causing the propeller to turn. It is a wild, wild design.
Oh, that is truly bizarre.
Isn't it? Yeah, and they talk about
beautiful.
like this sine wave of how the pistons work, and then you bend the sine wave around like a Mobius strip or something.
Right. Well, no, yeah, each one's going up and down, and it's just pushing this like tilt-a-whirl thing around, and that makes the shaft turn.
Ooh, this would make an excellent carnival ride.
How crazy. Yeah, it looks like those, I don't know what they're called, the big turny things that have the seats on them that fling the people out.
Oh yeah, that's what they're called.
I'm sure that's what they're called. My next hack this week is open source hot rod mod gives more power to EV owners. And this is the story of Daniel Oster's attempt to soup up his Nissan Leaf by giving it a different power inverter. If you think about old school internal combustion engine hacks, it's all about getting more fuel in there or getting more air in there or getting the mixture just right so that you can get more explosion. And the electric car equivalent of this is the inverter that takes the electricity out of the batteries and converts it into AC to turn the electric motors that drive the wheels. And at the heart of this Nissan Leaf is an 80 kilowatt inverter, which describes as being kind of anemic. And so he wants to swap it out for a newer 110 kilowatt inverter from a more recent Leaf. And his idea here is that if he can show how to do this, make it accessible, make it fairly inexpensive, a lot of people who own older vehicles can upgrade the horsepower they could put out simply by swapping out this inverter. And so it sounds really easy, right? And, you know, it's all just electronics. You just take out the old inverter, put in the new one, right? But it's a sign that we're living in the future, that today's motorheads have GitHub repositories because they have to go in there and modify code after they swap out the inverter.
Ooh, that is going to make an excellent t-shirt for the car hacking village at DEF CON.
What's this?
My garage has its own GitHub repository.
Yeah, totally.
Yeah, that's a good shirt. You just came up with it.
Totally.
So I got to say, this kind of drives me crazy because there's so much investigation that needs to be done just because the information about what's going on in the CAN bus is not public.
Yeah, the basic crux of the difficulty in this swap out is that the inverter has to know about the motor's specific phase of its physical turningness to its electrical phase. And so there's this calibration value in there that's actually printed on the motor for you called the resolver offset. And this is a value he has to figure out how to tell the inverter so that it can run with his motor. And he's lucky enough because he knows someone who has the appropriate Leaf diagnostic tools. And so what he does is he takes his car with its old 80 watt inverter in there and has his friend reprogram it with the same resolver offset because he doesn't want to break his car. And then at the same time, he's sniffing the CAN bus while it does this. And so he's got basically kind of a man in the middle or a replay attack set up here. He now knows what the commands are that he can send to the new inverter over the CAN bus once he's plugged that into his car, and how then he can convince the new inverter to use the correct resolver offset. And that's basically the hack here. While Dala has to man in the middle his old car to get the values into the new one, he's actually submitted these CAN codes to an open source Leaf-specific car flashing package so that other people will be able to do this easily in the future. I just think it's a really weird world that we're in now, that you have to reprogram the parts of your car to swap them out, but it's awesome that a dedicated hacker can do this fairly easily and then make the results of this work public so that everyone else can benefit from it.
Yeah, I don't know. I still there's got to be a reference manual for these cars internally, right?
Internally, yeah.
Yeah.
Or there isn't, and it's just all embedded in this proprietary tool, right?
Oh yeah, I suppose that could be it.
Like, you don't have to write it down ever. You just have to make sure all your authorized service stations are running the same software tool.
Yeah, I suppose, but someone wrote down what these values are for the different inverters when they designed the car.
It's just secret.
I know it's secret, and I know
These are
that
secrets kept from you about your own car.
There's no business reason to make the secrets available, but wouldn't it be nice? I mean, think of how nice it is when you buy fancy microcontrollers and they come with a 3,000 page reference manual that you only ever use 28 pages of most
Yeah.
of the time.
Yeah, right.
Right. But that other stuff is there for the people that are trying to use it. And like that is super interesting. And I just, when you have to go through so much work to find someone else that has the hardware and then to sniff it out and then to try it and see if it actually works on yours without bricking the thing, it'd be nice if there was just, a little bit more support there for people that want to screw around.
When you have to wrench on your car, there is nothing that's as nice as the service manual. I mean, where it tells you, how many foot-pounds you have to torque
Right.
this screw down to and what the right order is to get this part out and things like that. And that's kind of what's missing here. It's code. It's what the right CAN codes are. But I know what you mean. It should be better documented, but that's why we have hackers, to make the world a better place.
Well, from one car part to another car part, let's talk about the evolution of the Tesla door handle. Do you remember this original video from way back, like probably 10 years ago, that had the Tesla door handle that hides itself in the body of the car, but it was installed on a mini fridge?
I think I missed out on this whole Tesla fancy door handle thing, actually. I'm maybe the wrong person to ask.
I think I probably wrote the article.
Did you?
It's actually from 2012. That's when we covered it. I wrote this one. Tesla Model S handle dispenses beer, hides when done. And this was a hack that was pulled off by Superfast Matt, the person who is putting out the video that we're talking about today, which looks at the original Model S door handle and the current Model S door handle. And it is an awesome experience in iterative design. And the nice thing is that the door handle form factor is exactly the same, but the internals and how it actually works are completely overhauled. So the original had a whole bunch of electromechanical parts. It had 2 physical limit switches, like reed switches in there, and then 2 pressure switches and 1 pressure sensor. And all of that has been gotten rid of in the modern design of the handle and been replaced with a single magnetic sensor. And they're just using some clever mechanical tricks in order to make that magnetic sensor stand in for all of the physical switches.
Everything I know about Tesla door handles I've read on Hackaday.
I think an also a very neat part of this is when he goes through and looks at like how did these get replaced. You get to see like here is where one of the pressure switches used to be, and now there's just like a plastic spacer in there because they don't want to have to redesign the geometry of the other parts or like reshoot molds or anything like that. And so everything kind of has stayed the same. Now they have this magnet sensor in there that replaces the pressure sensors and the switches. It can just be potted, and it has been simplified so that the electronics are easier too. And this is where I hadn't heard of this before, this scent protocol. So it's this single edge nibble transmission protocol, which is a kind of a newer standard of bus communication that is kind of being adopted in the automotive industry, at least according to Superfast Matt. I have to say his comment right at the end of the video kind of made me smile, and it was, Tesla designs and builds some really awesome stuff eventually.
Was there a point in this? I guess the point was door handles create drag on the outside of the car. And so if you can have it suck into the car, it like streamlines.
Oh, yeah. So they're saying it reduces drag, but then Superfast Matt says that he talked to someone else who said it's in the wind shadow of the side view mirror anyway. So but if you ask me, this is what sold the car.
It looks cool. It looks hella cool.
Yeah, that's the thing. It's like it was the future. It's the robot that's going to be in your garage. It's like the hook, right?
It's the more cup holders
what else
to
does it do?
minivans.
Oh, yeah, that is a perfect analogy.
It's like loading your minivan with tons of cup holders and bigger cup holders so they fit your Slurpees. This one is the fancy door that makes it look like you own a space car.
Indeed.
Well, bringing up the rear, tracking maximum power point for solar efficiency. This is a video and extraordinarily detailed post on Instructables by Azkaz, aka Tech Builder. And I have to say, if you are going to mess around with solar at all, you absolutely need to check this project out. It is a deep dive into maximum power point tracking and how solar cells work, but then at the same time, how a lot of the other hacker designs for MPPT regulators have failed and how he's fixed them. And this is his 6th or 7th iteration on building an MPPT tracker. And in case you think this is a simple thing, this is for a solar panel that can put out a kilowatt and charge like 80-volt battery sets. This is the real deal, and it seems to be very nicely engineered. If you don't know what maximum power point tracking is, solar cells like to run at a certain resistance/voltage. There's kind of a water pressure analogy here. If you think of the solar cell as being a source of water, if you don't restrict it at all, the water just goes everywhere, big flow of water, lots of current, but no pressure. On the other hand, if you kind of dam it up, you can get high pressure water out, but in a much slower flow. It turns out that there's a maximum efficiency point with solar cells where this product of voltage and current gives you a maximum power. The problem with solar cells is that this maximum power point depends on how much sunlight is hitting the solar cell. And so you can't just set it once and you're good to go. You have to track this throughout the day as more and less light hits the solar cell to keep it at this sweet spot, maximizing its power output. And the device that does this for you is a buck converter that basically drops down the voltage coming out of the solar cell, reducing the flow of current and keeping it at its maximum efficiency. And this is where all the problems are. There's a lot of analog electronics here, but a buck converter is basically turning on a switch, charging up an inductor, and then turning that switch off. These switches get super hot, and one of the switches is usually implemented with a diode, and I don't want to go into this. You really need to look into Tech Builder's coverage of this if you want to see all the details of synchronous versus asynchronous MPPT trackers, etc. There's some really great engineering here, and it keeps parts from burning up, which is always good.
Well, and that is a pretty cool part of this build is that there are two versions, and one of them has a screen and some buttons on and the other doesn't, but both of them can dump information onto the web, and there's even like a cell phone app that you can look at it. But more importantly is then you can collect that information, plot it over time, and figure out how you're doing efficiency-wise.
Yeah, and I got so wrapped up in the awesome electronics of this project, I forgot to mention that I think he even wrote an Android app for it that does this logging for you. This is like a full stack hacker project here. And he promises a second video forthcoming that talks more about the power control circuitry. And I am waiting with bated breath for that to drop.
First up on my list of quick hacks, Banksy-like stock ticker shreds your money when the market's down. Now, this is going back to the Banksy art that was hanging on the wall that then after it was sold, shredded, or at least half shredded, the art off the bottom of the picture frame. If you don't remember that one, definitely go back and look it up. But this is a picture frame that you hang on your wall. It's kind of a shadow box with just a white area inside of it. But when your Dogecoin holdings go up, it will use a hidden money gun or dollar spewer, whatever you want to call it, to drop bills into the top of the frame on the inside. And then when your Dogecoin holdings go down, it will shred whatever money is sitting there in that frame. It's all in good fun, but quite well executed. And I was glad that Lewis Marks put this together and shared it with us. Next up, mastering stop motion through machine learning. Nick Bild put this one together, and it's based around a Jetson Xavier NX board, or maybe it's Xavier. I'm not sure which one that is. But the Jetson boards have been used for visual processing with machine learning algorithms. And in this case, it's looking for his hands in the frame of the camera. And as soon as he removes his hands from the frame, it will take one shot and save it to the stop motion video that he's putting together, which allows you to, as fast as you can put your hands in, make a tiny little turn to this Lego minifig head and then pull your hands out. You can make stop motion videos. And last up, Lego submarine gets balloon ballast system. I am still trying to wrap my head around this one, which is from the Brick Experiment channel. I think we've talked about some of their builds before, which do an awesome job of transferring power for the propeller and other, guiding surfaces out of the vessel without putting holes in the vessel. But in this case, they definitely put a hole in the vessel, and it's used to pump air out of the pressure vessel and into a balloon that's exterior and back in. And this changes the buoyancy and makes it go up and down. What I can't wrap my head around is you still have that air. So how is the buoyancy changing? And I figure the answer is pressure, but I'm going to do my research and maybe we'll get back to you on this one.
My 3 quick hacks this week all have to do with light. And they start off with Rodrigo Feliciano's bringing the Quake flicker to life with a hacked light. We ran an animated GIF of this one, and if you have played enough Half-Life or Quake or even modern Half-Life Alyx, you will notice the characteristic flicker of the broken fluorescent light effect. It turns out it's encoded in the game world in a series of letters. Rodrigo has dug this out and embodied it in a real light that he can sit on his desk and have it flicker like he is in Black Mesa. Next up, Broadband Across the Congo. This is a write-up of work done by formerly the Loon project from Google, now called Terra, where they're trying to send broadband by laser. Here they're creating a data link across a river where otherwise they would have to run cable the long way. Here they just shoot it across in the air. There's some clever active alignment of the optics here on both sides. It's really interesting to see how far sending data over light has gotten and how far it hasn't. This makes me think of the hacker Ranja project. The Ranja project is as old as dirt, and people are still working on kind of finessing around the edges to get more data through. It's nice to see progress there. And last up, DIY laser speckle imaging uncovers hidden details, and Fractuosity takes 2 pictures of laser speckle, one before touching the surface, one after. Because that speckle is an interference pattern based on the laser reflecting off of the surface and destructively or constructively interfering with itself, it means that it can resolve differences in height down to about the laser's wavelength, which here with a red laser is 650 nanometers. Turns out if you put your hand up on something, you leave about some fraction of that wavelength worth of oil or something on the surface. And comparing these 2 pictures can bring your handprint out from the chaotic laser speckle.
It's time for our Can't Miss Articles of the Week. This long-form content is written by excellent Hackaday authors, and this week I chose one by Maya Posh called Powering Up with USB, Untangling the USB Power Delivery Standards. Maya does a great job of digging into these standard references. I have to say this particular one, the USB PD standard, and maybe just USB Type-C in general, is super jargon heavy.
I was lost in acronyms here.
So she does a great job with that. And I think before you're going to open up the standard and read it yourself, this is a great primer to look at. And especially for people working in hardware, because the power delivery system is like a bench power supply built into every USB PD device, which is really cool. And we'll get into that in a minute. But yeah, let's talk about this jargon.
There's standard power range, SPR, extended power range, EPR. What else you got?
UFP and DFP. So upstream facing port and downstream facing port are common jargon in USB Type-C, and trying to go and find a definition of that is difficult. And if you think about it, it's difficult because the USB-C cables have the same plug on both ends, and devices can be a host or a device, right? They can be input or output. And so it's really you're standing on, an hourglass watching the sand slip away as you try to find your footing in this stuff. But at any rate, some cool things just to get us started. I think most people who have done anything that would be powered from USB know that you can get 500 milliamps at 5 volts out of any USB port anywhere without anything other than physical connections to the pins.
Right.
But if you want to get more than that, This is where USB power or delivery is amazing, because with just a resistor value on one of the pins, or maybe on two of the pins, you can get 1.5 amps or 3 amps at 5 volts out of there. If you want to do more than that, you can, but then you have to go to negotiation on a communications channel on the standard. And with that, the new R3.1 of USB PD implements EPR, which is extended power range, and that can do 48 volts at 5 amps, which is 240 watts going through your USB cable.
And this is part of the other reason that USB cables have gotten confusing these days, because when you're putting that much current through a small, cheesy little cable, it can't be a cheesy little cable, or else it's going to get hot.
If you have cables that are being sold out of spec, like that is a big concern. And I know there was some, I want to say like a Google engineer had their own webpage where all they were doing was buying cables off of Amazon and testing them to see if they were in spec. But yeah, it gets a little crazy. I mean, if you're going to plan to put this kind of power through a cable, you better have a certain trusted supplier for those cables to make sure what you're doing. But let's go back and talk a little bit about kind of the details of this. So I really liked Maya's comparison of USB-C to like having Ethernet running through it, like a half duplex Ethernet running through it. It has a packet standard that uses 32-bit packets at 300 kilobits per second and includes, CRC and all that good stuff, so that you can send data back and forth. And like the easiest thing to think on that is like, hey, device, what kind of power do you want from me? Like that's the negotiation that goes on those. But I was also interested and kind of went down the rabbit hole on her talking about the CC line, because she's like, there's only one CC line, it's half duplex. And I've read the pinouts for some of those ports before, and they have a CC1 and a CC2 line. So I'm like, why is she saying it's only one CC line?
Right.
It's so that you can plug the cable in any orientation. The plug, you can unplug it, flip it 180 degrees and plug it back in, and the thing still works. And so what you have is you have a CC signal, which is where the communications are, and then you have a VCON signal. And both that CC1 and CC2 lines need to be able to do either the CC or the VCON functions by the standard.
And so if you flip it around one way, they assign themselves one way, and if you flip it the other, they assign themselves the other to match?
Right, exactly. And so it's like, you could say the name of the pin is changing based on when you flip it over.
Super. So that whole confusion with like RX and TX, that's like 100 times as bad here, because it's actually the same pins just taking different electrical roles depending on how you've plugged the cable in.
So am I a VCON pin or am I CC pin right now?
Oof. But on the other hand, I understand all of this complexity, because if you're going to put 48 volts out of one of these little cables, you really don't want to put it into a device that's expecting to run at 5 volts, right? Like, these things need safeguards, and I guess it makes a ton of sense to make them complicated so that it doesn't happen by accident.
Well, then she even talks about unplugging the cable while that kind of power is going through it and having sparking when you do that. And she kind of in passing mentions that they have redesigned the physical standard just slightly for the plugs. So you have longer pins on the CC pins, I guess, in order to, when it senses that you're unplugging it, it can kill the power as quickly as possible, so you don't have that arc.
So they can get a little bit of a head start on you to pull it out.
Right.
Yeah.
Well, I was just thinking like mechanical problems, like someone sets down something heavy on the cable and it pinches the conductors inside it. Just like there's all kinds of, nightmare scenarios in here, which hopefully we'll never encounter. But even more jargon that's going on. Another reason that this might be interesting to you, I know you were just saying it's too complicated, Elliot, but
for me,
I see more and more of these jacks being put on people's projects, and I think that it's cool. And if we can get enough primers that help understanding for people designing hardware, I think we can get there. And kind of the place that was really interesting to me is the PPS and the AVS, which are the programmable power supply mode and the adjustable voltage supply mode. So in the adjustable voltage supply, you can increment the voltage that you're sending through the cable in steps of 20 millivolts.
Right, so you never have to design in a voltage regulator again. You just be sure you ask for the right juice.
Right. And I mean, the hope is, you get to more devices that are like single chip devices, like because everything that you need is done, negotiated through that chip's connection. And you don't need any external components. You don't need to have a buck converter. You don't need to have, really anything in there that deals with the power side of things. What could go wrong?
You just need to make sure you have the right cables on hand.
Yeah, you just think of it like, unintentional antennas and ESD, and like there's just a million problems with that statement. But at the same time, it's pretty neat that this is here.
My can't miss article this week is Hacking When It Counts, Surgery Fit to Save a Future King. This is a kind of a medical hacking write-up by Dan Maloney. The backstory here is marvelously medieval. Prince Hal, the future Henry V, lifted up his visor for a second in the middle of battle, and he gets an arrow in the face. He's such a tough future king that he fights on for another 3 hours with an arrow in his face, embedded in his skull, and eventually wins the battle. Ironically, the opposing leader, Lord Henry Hotspur Percy, lifted up his visor and also got an arrow in the face. Note to self, when in medieval combat, keep the visor down until you know the arrows are no longer flying. So the battle's over and somebody's got to save Prince Hal. This job comes down to the surgeon John Bradmore, and the point is embedded so deeply in the prince's face that he has to first stretch the hole back open so he can even get any work there. And then this is kind of, heinous. And this is kind of the medical hack aspect of this and the kind of forgotten bit of medical practice, which is that in the old days, surgeons, a number of them were also metal workers and they made their own tools. And what saves the day here is John Bradmore custom builds a arrowhead extractor tool to pull the arrowhead out of his face. And the tool itself has been recreated because he took notes about the making of this tool. And it's basically a thin needle that's split in half and has a screw that runs down the middle to expand the needle out. So he puts the needle screw thing into the arrowhead point, tightens the screw on the back, expanding it out, and is able to pull the arrowhead out of Prince Hal, saving his life, packs the wound with white wine, white bread, flour, barley, honey, and turpentine, and he lives to become king for 9 years before he gets brutally cut down in battle. But, c'est la vie, right?
I mean, put some honey on it. That's like going back to the Egyptians, right? Because of the antimicrobial properties in honey. Yeah, like honey doesn't have to be refrigerated because microbes can't live in it.
And what I thought was charming here was that he wrote all of this down. I mean, this was kind of a famous save, so of course you'd chronicle it. and John Bradmore lived the rest of his life on the king's dole. He was paid off well for this. I just think it's an interesting look back into a time when kind of the roles of doctors and surgeons and metal workers and actually barbers were all kind of wrapped up together, when the same people were cutting your hair or working on your teeth or doing minor surgeries on you, doing the fine metal work and making sharper knives and crazy extraction tools. And these two schools eventually kind of split off into the internists and the externists in medicine, and the barbers actually went way off to their own and only do hair anymore.
I like that Dan took a little bit of time to explain the state of the art in arrows and arrowheads for the time, and he also has some nice descriptions on the longbow and some studies for skeletal remains of archers showing that they had overdeveloped upper bodies and right fingers in order to be able to pull back because the force on the bowstring was so high from those giant bows, those 6 foot long bows. I am a little skeptical about the recounting of the future king fighting for 3 more hours. That sounds like something you'd say of your future king.
That's pretty tough.
Yeah, but maybe. I also liked it when you said that this was kind of a big save for the surgeon, like the future king.
Yeah.
The biggest.
Yeah.
There's no bigger save than that.
It could make or break your career, that sort of work, right?
It is great to get that lifelong pension, but I think Dan says that he only managed to live another 9 years after this.
Life was tough back then. I have to say, this article is a really sweet look into kind of this weird medieval medicine. It's a little bit off from our normal Hackaday fare, but at the same time, if Shakespeare were a hacker, this is the sort of stuff that I wish he would have put in the play Henry V.
That's all the time we have for this episode of the Hackaday podcast. As always, we'd love to hear from you. You can leave a comment on the show notes, which you'll find at hackaday.com/podcast. You can email us, editor@hackaday.com. We live and die by the tips that you send us, so if you do something cool or you see something cool, please let us know. tips@hackaday.com. And until next time,
keep on hacking.
Welcome to, we gotta sync. Perfect, we're sunk. I was giving you the segue. It was like the perfect segue too.
I think you're up first. Why am I down on quick hacks already? I guess still got one more awesome hack. And we'll just pretend it didn't happen. I am ready when you are.
It's your turn. Oh, what is it now? Shoot. Quit being a jerk, Elliot.